so question 1. It says the graph of y equals 5x squared plus 15x plus 3 has a gradient of a when x equals 4. We need to find the coordinates of the point on the graph that has a gradient of minus a. Okay, so let's go through this first bit. Quite a few people struggled on this bit when they first attempted this, okay? Now, if this is the graph, try and think about what the graph would look like. In this case, we know, because this x squared is positive, it's going to have a smiling U shape, okay? We don't know what the roots are right now. We're not really interested in the roots just yet, or I don't even think we are in this question. But what we know is that when x equals 4, it has a gradient of a. So we know that also that if x equals 0, to find the y-intercept, y would equal 3. So I'm just going to imagine it's something like that. Okay. Picturing the graph, it really does help, because it really does give you more of an understanding on what you're doing when you're solving this. Okay. Now, what is the gradient at any point on this graph? Okay, that's where we have to differentiate this. So if y equals 5x squared plus 15x plus 3, if I differentiate that, okay, so I'm going to differentiate y with respect to x. Okay, 2 times 5 for the coefficient, that gives me 10, and then the power reduces by 1 to give us 10x. In this one, the power is already 1, so 1 times 15 is just 15. And again, the power reduces by 1, so x to the power of 0 just cancels out because it's equal to 1. And this one doesn't even have an x, so we can't differentiate at that point. We just forget about the plus 3 there. Now, what I've worked out here, dy dx, is the gradient. Okay, so this represents the gradient at any point on this graph is 10x plus 15. Okay, so if it has a gradient of a when x equals 4, that means the mistake that people made here, which is understandable, they substituted 4 there, okay, and worked out what x is, but that's not the right thing to do here, because what it's saying is it's got a gradient of a. So if we know the gradient is a when x equals 4, it will be 10 times 4 plus 15. So a is 40 plus 15. So a is 55. Okay, that was just the first bit there. Now we know what a is. Okay, we want to find the coordinates of the point on the graph that has a gradient of minus a. So if a is 55, then minus a must be minus 55. Okay, and we want to find the coordinates. So what the coordinates of the points on the graph? Okay, so what is x and y when it has a gradient of minus a? Well, when does it have a gradient of minus 55? We know the expression for the gradient is this. So when does minus 55 equal 10x plus 15? Okay, solving this equation, subtract 15 from both sides. Quite a few people made the mistake of saying that's minus 40. Don't forget you're subtracting 15 from both sides. 15 less than minus 55 would be minus 70. So 70 is 10x. Divide both sides by 10. You get minus 7 equals x. So now we have our x coordinate. Now the next part here, people were getting confused. So how would you work out your y coordinate? You can't substitute that into the gradient because there's no function of y there. What we do know from the original equation though is that y is equal to 5 times whatever x squared is plus 15 times x plus 3. So we can figure out our y coordinate by substitution now. You need to be really careful when you're doing this, okay? And notice how I'm writing this out. And it is important that you write these things out, show you're working to maintain accuracy. And notice that I put the minus 7 in brackets. There was quite a few students who did this incorrectly because they're not using their calculator properly. So just to show you where that mistake is, it's a really easy and common mistake to make. When substituting this in, now first of all, if I put minus 7 squared into my calculator, what is minus 7 squared? Minus 7 squared, we know, will be minus 7 times minus 7, which gives us positive 49. So then why does it give me minus 49 on the calculator? Well, your calculator is not wrong, it's just really overly smart. It's thinking it does bid maths automatically. So you haven't defined that actually it sees it as this, 7 squared taken away. So it does the squaring first and then subtracts it. So to counteract that, to make sure we're getting it right, we need to make sure we write minus 7 and wrap that in brackets and then square it. Now your calculator knows it's not 7 squared being taken away, it's minus 7 squared, and it will give us the correct answer. Okay, so when entering this into your calculator, I'm just going to put it all in one line. So 5 times minus 7 squared plus 15 times minus 7. Now this one I didn't really need to put in brackets, but it's just good practice and a good habit to get into, plus 3. And that gives us that y is 143. Okay, so that means our final answer, we found our x and our y coordinate when at the point of the graph where it has a gradient of minus a, or minus 55, so that will be minus 7, 143. And then looking back at my sketch, minus 7 will be around here, and the gradient will be way up there. The y coordinate will be way up there, 143. And you can imagine that's going to be a very, very steep line. So hence it will have, and it will be negative, so it will have a gradient of minus 55. So if you imagine we've zoomed all the way up there, so if that's the graph going down like that, that's the point where it's minus 7, 143, and the gradient at that point, will be minus 55. And what we worked out earlier is that at point 4 it has a gradient of 55, and that is how you work out this question. It's important to get a full understanding, and if you can understand, and if you're sketching graphs and showing your full working, that's exactly what you need to be doing right now to maximize your understanding and your marks in this question. Okay, so question 2 says find the coordinates of the turning point of the curve with equation y equals 4x minus 5 over x squared. Okay, now there's a few things we need to take into account here, but we're going to start off with, let's rearrange this equation. Okay, I say rearrange it, just rewrite it in index form, because 5 over x squared, when we differentiate, it's not very helpful. Okay, just do a quick recap there. 5 over x squared. Okay, if it's a reciprocal, then we know that's like, well, let's say 5 times 1 over x squared first of all. And that's a reciprocal, which means it's going to have a negative gradient. So it'll be the same as 5 times x to the power of minus 2, or 5x to the power of minus 2. So if I rewrite that as 5x to the power of minus 2, okay, now it says find the coordinates, so x and y is what I want here, of the turning point of this curve. Now picturing this curve is quite difficult because it's a reciprocal graph. It's going to have a crazy kind of formation, so we won't bother with that. But what do we know about the turning point? Now if you imagine any function, so let's just say this is a random function that I've got there, okay, the gradient as this is going up is steep. So if you imagine the gradient is about the steepness of the line, what happens at the turning points there? Well, what's the gradient exactly at that point there? At the turning point, there is no gradient. It's horizontal for a little while before it starts going negative and having a negative gradient. And then again, at this stationary point, the gradient is 0. So at a turning point, that's one thing that we need to realize. At any turning point, the gradient, which we know as dy dx, equals 0. Okay, so first of all, let's work out our gradient of this function. Okay, if y is that, then dy dx, so if I differentiate that with respect to x, okay, the power multiplies by the coefficient, so we get 4, and then minus 1 leaves us with just 4, so x to the power of 0 is just 1, so it cancels out. And this one we've got to be really careful. Okay, if I multiply the index with the coefficient of x, okay, minus 2 times minus 5 gives us plus 10x, and then the power reduces by 1. Again, a lot of people wrote minus 1 there. Don't forget, if I rewrite that with the full working out, it might make a bit more sense to where people went wrong here. So in this case here, so that will be, if that's got power 1, that's 1 times 4, and then x to the power of 1 minus 1. So that gives us 4x to the power of 0, which is just 4. On this one, however, okay, minus 2 times minus 5, so I'm going to write plus there, but minus 2 times minus 5 as our coefficient of x, and then it will be minus 2 minus 1. So adding that bit there, that gives us minus 2 times minus 5 is plus 10, and then x to the power of minus 3. So that is dy dx, that is our gradient at any point. And what we know here, at the turning point, it equals 0. So when does 0 equal 4 plus 10 x to the power of minus 3? Well, we can find our x coordinate now. Okay, if I subtract 4 from both sides, that gives us minus 4. And again, some people did this using it still in index form. I would probably say it's a good idea at this point to rewrite that as in fractional form. So that would be 10 times x to the power of minus 3. So just to show you over here on the side here, 10x to the power of minus 3 is the same as 10 times x to the power of minus 3. And we know that negative power is a reciprocal, so it'll be 10 times 1 over x cubed. So in effect, we have 10 over x cubed. So 10, let me just rewrite that bit there, plus 10 over x cubed. And what you do, this avoids you having to find a negative root, so you're not going to find the minus third root. It's just not a nice thing to do mathematically. So if I multiply both sides by x cubed there, minus 4 times x cubed is 10, and then x cubed, I need to divide both sides by minus 4, so 10 divided by minus 4, and we know that 10 divided by 4 is 2.5, so it'll be minus 2.5, so our x coordinate will be the cube root of minus 2.5. So as I said, I noticed when my students were doing this in their test, some of them did that as kept it in index form. And just to show you, it wouldn't actually be wrong. There's nothing wrong with that. You still get it. It's just good practice to be able to go in between. I mean, if you're really going to aim for grade 9s, you should be able to go from fraction to index form and backwards to suit you whenever it does suit you. So let's find the cube root of minus 2.5, and that gives us minus 1.357 ... You don't want to round up at this point. It just loses accuracy. So I'm going to keep that as 3572. 3572 ... Yeah. Now, the reason why I say don't round it yet, we haven't finished the question. You should only round because we're going to substitute this in to find what our y coordinate is. So let's do that next. So y equals, and notice I'm going to change it back to this original equation. Okay, 4 times minus 1.3572 ... I mean, you don't need to write all of this out, but just little hints here of maintaining accuracy. Okay, that's what I want to enter into my calculator, and it actually makes your life easier because I've already got that answer stored in my calculator. So doing that all in one go, that will be 4 times answer, because it's stored it from before, minus fraction button, 5, press down, answer squared. And that gives us minus 8.143. Right, equals 8.143. Dot, dot, dot. So now we've got both our x and our y coordinate. Okay, and now I'd run around it to 2 decimal places, so it'll be minus 1.36 and that was minus, wasn't it? Double check that. Yes, it was minus. Important little things there that can cost you a lot of marks. So it should be minus 1.36 minus 8.14. Okay, so question 3, it says the function y equals x cubed plus bx squared minus 2, where b is a constant, has a turning point when x equals 2. So for part A, we need to work out the value of b. Okay, so starting here, okay, if we start with our actual equation there, so this function y equals x cubed plus bx squared minus 2, okay, it has a turning point when x equals 2, okay. What do we know about the turning point? We know here that dy dx, the gradient, is equal to 0, okay. So let's work out our gradient for this part here. So if y is that, dy dx will be 3x squared, so 3 times the coefficient, which is just 1 in this case, so 3 times x, and the power reduces by 1. Now in this case here, we're going to get it in terms of b, which is fine for now. Okay, so 2 times b will be 2b, and then x will reduce by 1, and then this one doesn't have x, so we can't differentiate. I'm going to get rid of that one because that's bad practice, it's just x there. Okay, so that's our coefficient. Okay, we know that at the turning point, when that equals 0, so when dy dx equals 0, x equals minus 2. So if I substitute in x as minus 2, I can now figure out what b is. So 3 times minus 2 squared plus 2b times minus 2. And again, notice how I wrap my negatives in brackets. A common mistake here, 3 times minus 2 squared is minus 4. It's not, because minus 2 times minus 2 will be positive 4. So 3 times 4, and then minus 2 times 2, minus 4b. So 0 equals 12 minus 4b. And now from here we can figure out what b is. Add 4b to both sides. 4b equals 12. And b will be 12 divided by 4. So b equals 3. Okay? So that's part A done. We've worked out the value of b. Now for part B, part 1, it says find the coordinates of the other turning point. Okay? Now going back here, we know that the turning point is when dy dx equals 0. And so far we had it in an expression with 2b. But now we know what b is. Let's rewrite that. So b part 1, dy dx is 3x squared. And then 2 times b, which is 3, will be plus 6x. So when does dy dx equal 0? And this is quite a nice function because we can factorize. So it gives us 3x, x plus 2. Okay? And now we can find our solutions. It can be if two things multiply to give you 0, either 3x equals 0, so x is 0, or x plus 2 must be equal to 0, so x is minus 2. Okay, we already had the turning point when x is minus 2. We need to find the coordinates of the other turning point. So when x is 0, what's y going to be? Okay, so when x is 0, because we're finding the y coordinate, again, students get sometimes mixed up. Should I substitute into this? This is the gradient. This isn't going to tell us our y coordinate. It's not part of it. Whereas this original equation will tell us what y is. So when x is 0, y equals 0 cubed plus, and it's bx squared. So remembering here that b is 3, so plus 3 times 0 squared, which is still 0, minus 2. So then y equals minus 2. So the coordinates of the other turning point will be 0, minus 2. Okay? Now, for part 2, I'm going to admit I was very harsh on giving my marks here. Okay? Is the turning point a minimum or a maximum? This is really your grade 9 understanding here. If you said that it's a positive x cubed graph, so it's got to be a minimum or a maximum, I gave you 1 mark there because you're almost there. But at this point, this is where you really need to have an understanding. Okay? We know now this is an x cubed graph. An x cubed graph looks like that. Okay? Because this has got plus bx squared, it's going to be a transformation of this graph. So it's going to be some kind of format where it's going to look something like that. Okay, it's just a sketch, it's not an exact copy, but we know it's going to be something like that. Okay, when you get to A level, you'll be able to kind of look at the equation and be able to know exactly how to plot the graph, if you can, especially when you can factorize things. But in this case here, because it's a positive x cubed graph, okay, it's going to follow that formation. Okay, and we already worked out the coordinates of our turning points. We know that our turning points are minus 2, and we didn't actually work out what the y value was there, but you can see there that that's a maximum, and then it goes down, and then at the point 0, minus 2, there, that would be the minimum. So the turning point there, it's a maximum there and a minimum there, and it carries on. So because it's a positive x cubed graph, you need to be able to sketch the graph. If you were going to earn that 2nd mark for this question, you needed to be able to sketch that graph and show me that you realized it's a minimum, and using the graph there. Okay, even though it says explain your answer, I mean, think about yourself. Would a maths teacher not accept a graph explanation? If you can picture this and you can graph it, that's where you're really working towards grade 9, and that's what would get you your 2nd mark in that question. Okay, so question 4, it says the height of an object above the ground h meters after t seconds can be roughly modelled by the equation h equals minus 2t cubed plus 11t squared minus 16t plus 7 for the interval where t is greater than or equal to 0 but less than or equal to 3.5. Okay, what that tells us so far, it's a negative cubic graph, okay, some transformation of a cubic. So between 0 and 3.5, if it's a cubic, I'm assuming it's going to have a turning point or maybe 2 turning points within that point there. Okay, now I'm going to start off by just rewriting the equation. So if h is minus 2t cubed plus 11t squared minus 16t plus 7, okay, now if that's the height, that's a distance. Okay, I'm going to model it as s, meaning displacement. Okay, and what that enables us to do then, if that's s, okay, we know to go from s to v, to go to the velocity, and notice it says there, after how many seconds will the object first be moving away from the ground at 4 meters per second. That tells us that we need to find either a velocity or a speed. Okay, So in order to go from a displacement or distance to velocity, that means you're going to need to differentiate here. I'm just going to write that like that. Okay, and if you wanted to, I mean, if this was carrying on and for future questions, if you differentiate again, that will get you to acceleration. I mean, just a little quick recap there. If this is a distance time graph or a displacement time graph, the gradient will be distance, the change in your distance divided by the change in time. So if you think about what you're working out there in units, that's meters over time. So let's say that's seconds, in this case, yeah, seconds. Okay, so meters per second is your gradient there. And when you're working out the gradient, that's what you're meant to be doing when you're differentiating there on a curved graph. And the same would apply. So if I did a velocity time graph, okay, your gradient here would be the change in your velocity over the change in time. So if you think about the units there, that will be meters per second divided by seconds. So in effect, it will be meters per second to the minus 2. So that would be an acceleration. That would be the gradient of a velocity time graph. Okay, but going back to this question now, so the first thing we need to do is, if I differentiate s with respect to t, okay, notice the changing in lettering there. It's just because I'm saying that this is some displacement, and displacement normally notation is usually s. Okay, if I differentiate s with respect to t, okay, this will be 3 times minus 2, so minus 6t, and then the power reduces by 1, so minus 6t squared, plus 2 times 11, which is 22t, and then again the power reduces by 1, making that just 22t, and then this one, 1 times minus 16, and then t to the power of 0, which means it cancels out, and then this will disappear because you can't differentiate that with respect to t. Okay, so now that's the actual gradient of s, which means that what we've worked out there is the velocity or the speed at that point. Okay, so after how many seconds will the object first be moving away from the ground at 4 meters per second? So when is the velocity equal to 4? Okay, now to solve this, we want to work out what t is when the velocity is 4. So let's subtract 4 from both sides to make it equal to 0. And just to make our lives a little bit easier as well, you can see these are all even numbers. So, well, that's meant to be 20, isn't it? Yeah, because we subtracted 4 from both sides. Okay. And what I'm going to do, rather than just dividing by 2, if I divide everything by minus 2, you get rid of the negative t squared there. So that gives us 0. In fact, let's change colour before we carry on. So from this point here, I'm going to divide both sides by minus 2. And because it's an equation, we can do that. Okay, that gives us 0 equals 3t squared. 22 divided by minus 2 would be minus 11t. And then minus 20 divided by minus 2 gives us plus 10. Okay. Now from this point here, you can either solve by using the formula, although at this point, especially those looking for a grade 9, you should be able to factorize this. Okay. You can either use the AC method, and I'll demonstrate both there, but if that's 3t squared, I use a grid to factorize because I just think it's easier. But you're more than welcome to have your own ways of factorizing. So that means I need 2 brackets, okay, so which will be on the outside here, and those will multiply together to give me 3t squared, your middle 2 terms, so I'll know I'm doing it correctly if these 2 add together to give me minus 11. And more often than not, they're going to be primes, so that will be 3t and t. And let's try 5 and 2. That gives me 6t there and 5t there. And as you can see, that does give me, I can make 11 out of 5t and 6t. But because it's got to be minus 11, that means it's got to be minus 2 and minus 5 to to make them both negative, and just to check, minus 2 times minus 5 gives us the plus 10. So I factorise into those two brackets 3t minus 5 and t minus 2. So solving this, either 3t minus 5 equals 0, so 3t is 5, and then t is 5 over 3. If you want, you can change that to a mixed number, so that's 1 and 2/3 of a second. And it's either that one or t minus 2 equals 0, so t equals 2. So again, you can use the formula, you can use the AC method, whichever method you want to use to factorize that, but you should be able to factorize this at this stage to really kind of make sure you're getting your understanding. Now, the last mark here, a lot of people lost because and they wrote their answer, so if you imagine if that's the answer line, 2 seconds. And I can understand because that kind of looks a bit weird, and you're used to normally getting like a negative one, which is invalid, and you just kind of keep that one. So I understand where this mistake has come from, but that is incorrect because it said after how many seconds would the object first be moving away from the ground at 4 meters per second, and when it will first be moving will be at this point here, 1 and 2/3 seconds. So that is the correct answer there. Okay, so just be really careful about little things like that. It's very, very tricky. Okay, and because it's a cubic graph, I mean, if you think about the height of an object, because it's being modeled by this equation, there's nothing to suggest that it won't be moving away from the ground at 4 meters per second twice. You know, for example, if it's a projectile, and I mean this, if it's been thrown and then it went down and then back up again, and you know, if this was 4 meters per second as the velocity, it can have 2 points there. So this would be 1 and 2/3 seconds, and that would be 2 seconds. There can be 2 times when it's moving away from the ground at 4 meters per second. But in this case, it wanted when will the object first be moving away from there, which would be this answer there. Okay, question 5, it says a farmer wants to fence off a triangular piece of land, so the base length is 4x plus 1 kilometers, and the vertical height is 6 minus 2x kilometers. Okay, we need to first find the upper and lower bounds for x and give our answer as an inequality. Okay, so first of all, I mean, if you're not doing this already, you should get into the habit of drawing a little diagram and picturing what's actually happening here. So we've got this triangular piece of land, and what we know about this is the base length is 4x plus 1, and the vertical height is 6 minus 2x. Okay? Now, for part A, it's saying what are the lower and upper bounds? What's the maximum and the minimum that x can be? Well, I guess the smallest that x can be, it can't be less than 0. In order to be a triangle, that means 6 minus 2x has to be bigger than 0, and 4x plus 1 has to be bigger than 0. So using these inequalities, if I solve those, add 2x to both sides, divide both sides by 2, that means x has to be less than 3. Okay, on this side, 4x will be bigger than minus a quarter, and then x has to be bigger than, sorry, that was minus 1 there, you need to divide by 4 afterwards, just jumping ahead there. Okay, and divide both sides by 4, you get minus a quarter. Okay, so as an inequality, what that tells us is that x has to be bigger than minus a quarter, but less than 3. Okay, and then it will fit into that triangular motion there. Okay, and there's, I mean, you could also work out what the area is and, you know, work out the roots. I mean, let's do that anyway, just to be a bit extra. If I work out the area of this, okay, that will be 4x plus 1 times 6 minus 2x, and base times height divided by 2 for a triangle, which gives us, I'm going to rewrite that just to make it a bit easier, minus 2x plus 6. So that gives us minus 8x squared plus 24x minus 2x, and then plus 6 over 2, which simplifies to minus 8x squared plus 22x plus 6 over 2, and then we can divide, because they're nice and even, all of those, we can divide that again into minus 4x squared plus 11x plus 3. Okay, if you solve this, so we know that this represents the area has to be bigger than 0, otherwise it's not a triangle and it won't have any kind of land there. So you could rearrange that as an inequality. So if I solve this first, so if I make that equal to 0 and solve it, let's divide everything by minus 1. That gives us 4x squared minus 11x minus 3. Let's factorize that. That's a prime number, so it's got to be 3 and 1. This could either be 2 and 2x times 2x or 4x. Let's try 2x first, see if that works. That gives me 2x there and 6x there. That will not give me 11, so that's not very useful. So let's try 4x and 1. That gives me 4x there and 3x there. That clearly didn't work, so let's try it the other way around. Let's try 4x there and 1 there. That gives me, so that mentioned 1x. And then that will give me 12x. And now you can see I can make minus 11 out of those. If I do 1 take away 12, so if that becomes a minus, that gives me my two solutions there. So 0 equals x minus 3 times 4x plus 1. So my two solutions there, x equals 3, and if 4x plus 1 equals 0, then x will be minus a quarter. But then doing it this way, you've got to realize, so using this graph here, what we've figured out there is, because it's an x squared graph, we know that the roots are 3 and minus a quarter. So that's what this will look like. Okay, and using this one here, when is that? That's got to be less than 0, because we divided by a negative. So it's got to be between minus a quarter and 3. So when x is bigger than minus a quarter and less than 3, that will give us the value there. Again, it didn't need to be this complicated, but I just wanted to show you that actually there's lots of different ways. But the key thing to realize there, because we're looking at, and I guess when we're looking at worded questions involving land and things like that, it has to be positive there. So that's how you work out part A. Okay. Now for part B, it says find the maximum possible area that the farmer could fence off. Now luckily we already worked out our area, so I'm going to take that from here. So our area is minus 4x squared plus 11x plus 3. Okay. So thinking about it like this now, we've got a negative graph, okay, because it's minus 4x squared, okay, and I mean, we know that the roots are 3 and minus a quarter, so minus a quarter and 3, so it's going to look something like that, okay, and we want to find, so this is representing the area, so the area is given to us in terms of x. So when is the area at its maximum point? Well, that's going to be, so at the maximum point, our gradient here, dy dx, has to equal 0, because it's a turning point there. The gradient is going upwards and then it becomes horizontal, so the gradient itself will be 0 before it turns negative. So at that max point, dy dx equals 0. So again, 0 equals, so if I differentiate this now, 2 times minus 4 gives us minus 8, x, and the power becomes 1. And then that'll be 1 times 11, so plus 11. And then again, x reduces by power, so it just becomes minus 8x plus 11. So what is x when the gradient is 0? Well, let's add 8x to both sides. So x will be 11 over 8. So now we've worked out what x is. If you want to work out the actual area now, which is what the question was looking for, okay, again, you don't substitute into the gradient formula, okay. Notice in fact, I should probably, this was bad practice here, that wasn't dy dx. What we actually differentiated here, we were differentiating a with respect to x, okay. So now we know what x is. If I substitute that into here, I can work out my area. So my final part here, if a is minus 4x squared plus 11x plus 3, then my area at its maximum point is when x is 11 over 8, so minus 4 times 11 over 8 squared plus 11 times 11 over 8 plus 3. And we just substitute that into our calculator. So minus 4 times bracket, fraction button, 11 over 8, close bracket, squared, plus 11 times bracket, and you don't need the brackets here, it's just, I just like to do it to keep things neat and tidy and avoid little mistakes, plus 3, which gives us an answer. So A is 169 over 16, that was. Which is an interesting answer. I mean, again, you grade 9ers should be looking at that and thinking, oh look, that's 13 squared over 4 squared, which doesn't really mean anything in this case, but it's just an interesting point there. And if you wrote it out, your area will be 10.5625 kilometers squared. It was kilometers, yeah. So that would be the maximum area. So if you think about what we're working out here, in these maximum and minimum problems, okay, now think of it yourself as a landowner, okay, you've got this triangular piece of land and you've got a variable, so you can actually change what the height and the width is. So imagine you own a huge piece of land and you need to fence off this triangular piece of land, but you want to maximize that area. What we've just done there mathematically is work out what x has to be, what our variable has to be to maximize the area, okay, and we've also found what the actual area itself would be at its maximum level. Okay, question 6. The displacement s meters of a tennis ball from the net after t seconds can be modelled by the equation s equals minus t squared minus 4 over t plus 20, where the time interval is between 0.2 seconds and 5 seconds inclusive. Okay, we need to find the time at which the tennis ball is decelerating at 3 meters per second or 3 meters per second squared. Okay, now first things first, what we need to realize here is what we've been given is the equation for s, which is the displacement, so minus t squared, and again I want to write that in index form, so it'll be minus 4t to the power of minus 1 plus 20. Okay, just a quick reminder there, so if you've got minus 4 over t, that's the same as minus 4 times 1 over t, and then t, you can rewrite that as t to the power of minus 1. Okay, so what we need to do here is we're going from displacement to velocity and then to acceleration. Okay, so we need to differentiate this twice. So if I differentiate s with respect to t, that will give me the velocity. So that will be 2 times minus 1, so minus 2t, and the power reduces by 1, so it will be just minus 2t. And then minus 1 times minus 4 gives me plus 4t, and then the power reduces by 1, so it will be t to the power of minus 2, and this doesn't have t, so we can ignore that bit there. Okay, so that is our equation for velocity, but velocity is not necessary because what we want is acceleration. So now I need to differentiate v with respect to t, which will give me the acceleration. And if I differentiate this, so that's got power 1, so 1 times minus 2 is just minus 2, and then t becomes 0, t to the power of 0, so it becomes 1 and cancels out. Minus 2 times 4 is minus 8t, and then minus 2, remembering here a common mistake that some people wrote that as minus 1, it should be minus 3 when you take away 1 from 2. Okay, so that tells us our acceleration is minus 2 minus 8t to the power of minus 3. Okay, now what's tricky about the wording in this question is that the ball is decelerating at 3 meters per second squared. So if I mean, think of it like this, okay? What that's telling us that our acceleration will be minus 3. And that was the main mistake that people made there. So when the acceleration is minus 3, when it's decelerating at a rate of 3 meters per second, minus 3 equals minus 2 minus 8t to the power of minus 3. Okay, now to solve this, first let's add 2 to both sides, so minus 1 equals, and I'm going to rewrite this in fraction form, okay, so it'll be minus 8 over t cubed. Okay, just doing that in itself just kind of helps you to solve this. Again, grade 9ers should be looking to be able to convert between index form and fractions easily like that. Okay, just to show you why that works. So if I've got minus 8t to the power of minus 3, that's like saying minus 8 times t to the power of minus 3, or minus 8 times that's the reciprocal because it's a negative, so it'll be 1 over t cubed, so it'll be minus 8 over t cubed. Okay, and now if I multiply both sides by t cubed, that tells me that minus 1 times that, minus t cubed equals minus 8, times both sides by minus 1, gives us t cubed is 8, and then t will be the cube root of 8, so t is 2 seconds. Okay, so the key thing to take away from that, it's again, it's a nasty question in the way that they've tricked you with the decelerating. It shows you just how much you have to take into account the wording of the question. If it's decelerating at 3 meters per second and we worked out our acceleration, okay, that means our acceleration at this point will be minus 3 meters per second squared. Okay, so that was the key area that people went wrong on that one. Okay, question 7. A solid right circular cylinder has radius r centimeters and height h centimeters. The total surface area of the cylinder is 800 centimeters squared. For part A, we need to show that the volume v centimeters cubed of the cylinder is given by v equals 400 r minus pi r cubed. Okay, so for part A, okay, it's helpful, and I always think it's a good idea if you just kind of picture what we're doing here, especially for the people that made the most common mistake that was made when doing this. Okay, we've got a cylinder with radius r and height h. Okay. Now, what's been told to us is that the total surface area of the cylinder is 800. Okay. So if we work that out first, okay, our total surface area will be 2 pi rh, which is the curved cylinder part. Okay, why is it that? If you think about this, if you were to unfold this cylinder, okay, you would get a rectangle as the curved part, and the top part there would be the circumference of the circle because it has to wrap round, hence it's 2 pi r, or pi times diameter, and then you multiply it by h to get the area of that part there. But don't forget, that's not the only part of the cylinder. For the total surface area, you need the top and the bottom circles, so we need 2 pi r squared there as well. So that's the key area where some people lost marks immediately, is forgetting that actually for the total surface area you need the circle at the top and the bottom. Okay, and what we know from this, we know that the total surface area is equal to 800. So 800 equals 2 pi rh plus 2 pi r squared. Okay, to make things easier, they're all even, so let's half everything. And you can already see we're starting to get to that. So 400 equals pi rh plus pi r squared. Now, we want h to be the subject here, and there's two ways of doing this. Okay, if I make h the subject of this formula, then I can work out the volume formula to work out what the actual volume. So let's make h the subject here. So if I subtract pi r squared, so 400 minus pi r squared equals pi rh, and then divide both sides by pi r, that will give us what h is. Now, I want to address a common mistake that was made here. Okay, what you can't do is cancel out pi or r at this point, okay, because they're being added or taken away. If you notice, there's the only time you can cancel, and just to illustrate that over here, okay, if I have a fraction, say 3 plus 2 over 5 plus 2, okay, now just adding those, we know that that's going to be the same as 5/7. Okay, if I cancel those out, that 3/5 is not equal to 5/7. The only time that cancelling can take place, if I had 3 times 2 over 5 times 2, well, that gives us 6/10, which simplifies back down to 3/5. So you can see those can cancel out quite easily, but this cannot. Okay, and so that's why you can't cancel out the pi r squared, because it's being taken away, it's not being multiplied, so those won't cancel out at this point here. But now that we've got h as the subject, okay, the formula for volume of a cylinder, and let's change color over here. Okay, so the volume of a cylinder is going to be, for any kind of 3D shape that's a prism, okay, you find the area of the front face, or one of the faces that's being repeated, and multiply it by the length or the depth of that shape. So in this case here, our shape will be pi r squared times h. Okay, and that formula is given to you if you're doing the IGCSE, so we don't need to worry too much about that. But now that we know what h is, okay, as in terms of pi and r, I can multiply pi r squared by this to give the volume. So in this case here, if you think of it like this, pi r squared over 1 times 400 minus pi r squared over pi r. So just as we were saying earlier, because they're being multiplied, they can cancel out, because in effect you can simplify it like that. And because these are being multiplied, pi will cancel out, and one of the r's will cancel out. So we're left with v equals r times 400 minus pi r squared. So then the volume, timesing both of those by r, gives us 400 r minus pi times r squared times r, or r cubed. And we have derived that then. Okay. Now, also another thing that I wanted to point out there was a really clever kind of way of doing this as well that some students spotted. So if you did this, well done to you guys, because this was a really clever way of doing this. Okay. So similar kind of concept. Okay. But knowing that V is pi r squared h. Okay. They got to, I think it was this point here. So imagine we've done that bit there and we got to 400 equals pi r h plus pi r squared. Okay, and what they noticed there was that these two are only separated by r. Okay, so if I multiply all of these by r, 400 r equals pi r squared h plus pi r squared. Okay, and if you notice then I can now substitute that as volume. So 400 r equals, so instead of writing pi r squared h, I can write v plus pi r squared. So then v, taking away pi r squared from both sides, would it be pi r squared? Oh no, that should be cubed, because we multiplied by r. So that gives us v equals 400r minus pi r cubed. So another clever way of, if you recognize that from the volume formula, that's really high level work, and well done to you, because that's a really good way of solving that. Okay, but that's just part A so far. I'm just going to get rid of this so I've got a bit more space. Now for part B, it says, given that r varies, find the maximum value of v to the nearest centimetre cubed. Okay, what that basically means is, now imagine the graph of this. This is a negative r cubed, so it's a cubic graph that's negative. Okay, what that tells us immediately, and what you should kind of picture in your head at this point, we know that r cubed will look like that, where it goes through the origin up there like that, but this is negative, so it's going to go the other way around. And because it's a transformation of r cubed, it's going to look something, and again, it's not accurate in any way, but it's going to look something like that, where you could have a minimum or a maximum. Okay, so at a maximum point, if this represents v, okay, if I differentiate v with respect to r, okay, we know that v equals 400r minus pi r cubed. Okay, so if I differentiate that, okay, at its maximum point or a minimum point, okay, so at max or minimum point, we know that dv dr, or the gradient, will equal 0. So the gradient there is going downwards and it becomes horizontal, so it's 0. So at max and min points, the gradient is equal to 0. So going back to this, working out the gradient, okay, in this case that's got a power of 1, so 1 times 400, and then it becomes r to the power of 0, which is just 1, so it cancels out. And then this bit, this is another place where quite a few people made mistakes. Now if I multiply the power by the coefficient, this in this case it will be minus 3 pi r, and then the power goes down, so it will be minus 3 pi r squared. Okay, so we want to know what is the radius when it's this gradient is 0, and that will tell us either the maximum or the minimum point. So 0 equals 400 minus 3 pi r squared. Add 3 pi r squared to both sides to make that positive. Divide both sides by 3 pi. And then r will be the square root of 400 over 3 pi. You don't need to work this out, but I'm going to on the calculator anyway, because it will help a little bit further along. So square root, fraction button, 400 over 3 times pi, and that gives us a radius of 6.51 ... Now, as I said, I would keep it in terms of r, because we haven't worked out, we want to work out the maximum value of v, okay, so we need to substitute, now that we know the maximum, what r is at its maximum value, if I substitute that in, So V equals 400 r minus pi r cubed. I'm going to substitute this value in, so it'll be 400 times the radius, so square root 400 over 3 pi minus pi times root 400 over 3 pi. And again, even though that's a lot of writing, it avoids you having to round this up, which just causes a little bit of inaccuracy, but it's not a big deal, to be fair. Okay, so also because I've got that answer stored in there, I can now just press in my calculator 400 times whatever my answer was minus pi times answer, and that's cubed, isn't it? So times answer cubed, and that gives me my maximum volume of 1737.253. So we can just state, it doesn't, to the nearest centimetre cubed, good thing I reread the question there. So to the nearest centimetre cubed, that will be 1,737 centimetres cubed. Okay, now for part C, again, this is really your grade 9 type question. Even though it's only worth 2 marks, those are very important marks because it's really testing, do you understand what the graphs look like? Okay, in this case here, in order to justify whether you found a maximum or a minimum, first you can see from here, okay, if it was a minimum, okay, I'm just going to rewrite that graph, so just to kind of remind you there, it's a negative x cubed graph, okay, and what we've found out here is it's got a minimum point and a maximum point. At its maximum point, when the radius is 6.5, the volume is 1,737. And the reason why we know that it's got to be a maximum, because it's a negative cubic graph, okay, it means then the first minimum, so at that point there it will have a minimum point, but it will have a negative minimum point there. I mean, you could work it out from V there. If V equals 400 r minus pi r cubed, okay, to find the roots of this equation, we won't go into the full roots of that, but we can factorize by r. Okay, that means either r equals 0 or 400 minus pi r squared equals 0. So 400 equals pi r squared. R squared will be 400 over pi, or r equals the square root of 400 over pi. And don't forget what that means, it's going to be plus or minus square root 400 over pi. So that tells me that it's either going to be, my roots are going to be, in fact, I mean this graph would be wrong then, because going back to that original graph, okay, we know it's a negative cubic. We know that it's got roots at 0, and I'm just going to say plus 400 over root 400 pi and minus. And if it's coming down as a negative graph, that means it has to be coming down this way. It's got another root there, and it's going to have a maximum point and going down there. And we already know that at the maximum point, r was 6.5, okay? And it had a maximum of 1737. And because it's plus or minus for this bit, that would be your positive root, that would be your negative root, which would be the minimum. So it's using the graph to show that because it's a negative cubic graph, the minimum will be negative, a negative value of r, and for your positive, for your maximum, it will be a positive value of r, and that's what would get you. I would want to see the sketch of this, okay? So the key things to take away from this part C that you get in these when you're justifying whether it's a maximum. If you can sketch the graph, that's when you're working towards those marks, and if you're really heading towards an A-level understanding.